In this video, we're going to be working with how to factor if you have a negative exponent or any sort of fractional exponent. So let's take a look here at this first one. You'll notice that we have fractional exponents, which really shouldn't scare us. If we do have a fractional exponent, let's make any fraction that's showing into a mixed number. So 2 divided by 3, there's only 1 2 found in 3, and we have a leftover of 1. So this leftover is really 1 over 2. So your mixed number is 1 and 1/2. So we can go ahead and rewrite x to say x to the 1 and 1/2 minus x to the 1/2. So they both share an x to the 1/2 in common, in which case we're going to factor out x to the 1/2. And we're left over, we have x to the first power minus, we took all of this x to 1/2, so minus 1. So our final answer should be x to the 1/2 times x minus 1. Or if it's a fractional exponent still, we can put it back into a radical. The reason why we can put it into a radical is if we have x a over b, it's equal to b root x to the a. And we can go back and forth with them as well. Now, anytime you have a negative, when it's a negative, you're going to take the more negative fraction and you're going to take that out completely. So between these two, right, we're going to take out all of this negative, or x to the negative 2 over 3 power. Now notice that as well in your coefficients, 4 and 8, they both have a 4 in common. So we're going to factor out essentially this whole term. So you're left with 1 to be here. And when it comes to this fraction here, x to the 1/3, when we're wondering, okay, well, when you factor out the negative 2 over 3, what is left over here? So we can make a quick example or a quick setup. We can say, in order for us to keep this 1/3, what value, and I'm just going to say a minus, or a plus the negative 2 over 3 that got factored out, what will be our new x exponent? So by doing so, you could say plus a negative, or you can just say subtract, right? Because you took it all out. And to solve for a, we're now adding 2 over 3 plus 2 over 3. So we have 3 over 3. So a, when you factor out this negative 2 over 3, you're left with 3 over 3, or a remainder of 1. So we have negative 2, leaving behind the 8, and x. The reason why we did this is that when we go backwards, when we insert this back, we would have x to negative 3 over 2 times x to the first. But because our properties of exponents say when we are multiplying your bases, we're really adding your exponents. So this addition of your exponent, negative 2 over 3 plus 3 over 3, you're left with 1/3. So when you go ahead and redistribute it in, you're left with the 1/3. And your final answer, if you would like, because you have a negative exponent, and 4 has an exponent of just 1, the reciprocal, if you have x to the negative a, we're going to do 1 over x to now a positive a. To keep in line with that rule, we're going to keep 4 where it is because it has a positive 1 in its exponent. 1 minus 2x over x to the 2 over 3. It's now positive. Or if you prefer, you can write it as the cubed root of x squared. Now let's try it again over here. So of these two, you can tell that they actually have this whole x minus 5 in common. So this whole thing, x minus 5, will be taken out. And as far as its exponents go, you're going to take the more negative number. So you're going to be taking out this negative 3 over 2, leaving behind, or if we're taking out this whole term here, we're leaving behind the coefficient of negative 1. And in its place, what is left over? So just like we did with the 1/3, we're going to write r's of negative 1/2 is equal to a, what do we want our new exponent to be? Minus the 3 over 2 that we took out. We can add 3 over 2. So then a is now 2 over 2. So that just means for your x minus 5 remaining, the exponent is 2 over 2 or just 1. In which case we can combine on the inside. So you get x minus 6 on the inside. And because this whole thing has a negative exponent, the remaining of it will come down here. X minus 5 to the 3 over 2, it's now positive. Or if you prefer, you can put it back into a radical. Let's try it again. So 12 and 8, they both have a 4 in common. So this 12 is going to leave behind a 3, and this 8 is going to leave behind a 2. Now, of your fractions, we're going to take out the most negative fraction, so negative 3 over 4. So in this first term, you took out all of the x, but you're leaving behind a 3, minus the 2 left over from the 8. And let's see, what do we leave behind for your exponent? If we want 1/4 to come out when we redistribute, a minus 3 over 4 that we took out, we can then add it over. A is now 4 over 4, or just 1. So one more time, if we put it back in, we have 4, 3 minus 2x over x to the 3 over 4, or again, if you prefer, the 4th root of x cubed. Now let's try it again on our next one. So your coefficients don't have anything in common, so that can't get factored out. But we do have this 4x plus 3 to take out. 4x plus 3 will all come out. We're going to take the more negative exponent. So we're going to take out the negative 2. So that just means this whole term is gone. But in its place, we still have this minus 4. And I'm just going to move this ever so slightly. And move that one over to make room. Negative 4, 5x plus 1. And then in its place, right, if a, we want negative 1 to be left, we have a minus 2, so we can add 2 to the other side. So a is going to be positive 1. So in its place, we're left with 5, 4x plus 3, just 1 left behind. So now we can go ahead and distribute. So we should get 20x plus 15 minus 20x minus 4. Those 20x's are going to cancel. And let's see, we have 15 minus 4, so we get a negative 11. Here's our positive 11. So our final answer should be positive 11 up top over 4x plus 3 squared on the bottom. Now, because that one is not a fractional exponent, we're not going to be dealing with any sort of radicals. Now, your last one, we're going to think about in chunks. So, looking at this first term, what can simplify? Well, the two x's, or the two negatives can simplify. You have 1/2 and a 2, which will also cancel. So over here, you're left with 3x squared 1 minus x squared to the negative 3 over 2 plus 3, 1 minus x squared to the negative 1 half. So you can tell they're going to take out a 3, and we're going to take out a 1 minus x squared. We're going to take out the more negative of the 2, which means we're going to take out all of this term, leaving behind an x squared. In its place, we've taken this one, and we're going to leave behind just one of these. Your x squareds cancel. We're left with 3, because that has an exponent of 1, it's positive, over 1 minus x squared to the 3 over 2, or if you prefer, and that is how you can factor with negative exponents and fractional exponents. They can give the next remaining ones a try just by trying to simplify the fractions by canceling out what they have in common. And I'm going to show you the answers here in a moment. You'll notice that they did not put these back into a fractional exponent or a radical exponent. Based on the teacher preference for me. Because you started with a fraction, you're likely confident in keeping it, but it is a better notation to have the radical here.